Okay, so we are live for module 2 part 1. Okay, so join up. Alright, hello, you're welcome to this section. Okay, so let's try to see what we can do. It's currently not showing my board. I don't know. Let me see if that can be rectified. Maybe it's my network. Okay, I think it's still the same thing. It's still not showing the board. I feel it's from the board. Let me exit or quit the board and then come back again. Okay, the board is showing red. Okay, let's see, just a moment. Okay, it's still not showing the board that I want. Okay, I don't know why. I'll try to get it rectified. So just a moment. Let me check my okay, are you sure this is not the reason? Okay, let me try writing since it's not showing what I want. Let me try writing. Okay, so here we are told for problem 1 we are told wow, it's still not showing. What's happening to my board? Okay, permit me to work on it and then try to see what's happening. Okay, I think it's back. Okay, yeah. Okay, sorry for the whole delay. Okay, so let's go now. Problem 1. Okay, so it says copy and complete the following. Copy and complete the table below, and let me see if I'm able to show you the table. Okay, so first we are given equations. It started with Sn. Let me come down. Sn, and then we have equation. Maybe I should reduce this. Okay, so equation, and then after the equation, let me give maybe this kind of space. Okay, so after which we are giving order, and then after order we have degree. Okay, and then after degree we have linear. Okay, and then after linear we have homogeneous. And after homogeneous we have autonomous and non-autonomous. Okay, so the intent is that they will be giving us equations, and then they are expecting us to fill in the details. Okay, so look at the first one. Y prime plus 2y raised to the power of 1/3 equal to sine x. Okay, so the order is 1, highest derivative present is 1. The degree we can actually rewrite this by multiplying both sides or raising both sides to the power of 3. If you do that, you're going to have y prime plus 2y. That power 3 will cancel this, so it will come to this side and we'll have sine cube x. This is a perfect nature for this, so we can see the degree, which is the order, which is 1, and the degree is the power of y prime, which is also 1, and then whether linear or not linear, it is linear. Okay, because it satisfies all the conditions. And then homogeneous or non-homogeneous. Okay, so non-homogeneous, and then autonomous or non-autonomous. You can clearly see it is non-autonomous. Okay, so these are the things we are expected to do for the other ones that will come up to 6. Okay, so but I'll be back in a while and then we'll continue. Alright, so sorry for that delay. Okay, so I will ensure to as well remove it from the video so that other people that will watch the recorded video will find time to not see the elongated width. Okay, so this is actually what we are being asked to do, fill in all of this for the equations that we are going to be given. Okay, so the next equation is like this: y prime prime raised to the power of 3 then plus 2y prime then multiplied by y prime 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 all equal to 0. Okay, so what's the order of this? The order is the highest derivative present, which is 3, and for some of these they use their hand in filling it for you, so you just take notes. Okay, like this one, non-autonomous was filled, linear was filled, so we're just to fill the other 3. Okay, so here this is empty, this one is filled, and that's degree is 1. Okay, and how is it 1? Because the power of the y with the highest derivative is 1. Okay, now is it linear? No, non-linear, and is filled actually. So why is it non-linear? There is a derivative that has power of 3, and then again there is a product of y prime and y prime prime prime. All right, so once you have the product of y and its derivative, or a derivative and another derivative, then what you have is a non-linear function. Now, is it homogeneous? Everything is equal to 0. Okay, so it is homogeneous. It's homogeneous, of course. By the time you put in you put in all the things that you need to put in, you discover that you can factorize out your case, so it will definitely give us that. All right, so is it autonomous? Yeah, number 2 is autonomous. Of course, you are not seeing any y there, any x there, right? So it's all in y, so it's autonomous. All right, so in this case, this and this were filled, we are to fill the other 3. Okay, so number 3, the equation we are given is y prime prime minus y prime raised to the power of 2 then plus x squared y all equal to 0. Okay, so let's go. What's the order? The order is 2. Okay, what's the degree? The degree is 1. Why is it order 2? Highest derivative is 2. Why is it degree 1? The power of the highest derivative is 1. And is it linear? Of course, it's non-linear because of the square of that degree 1 there, so it's non-linear. Okay, so non-linear. And then what else? Homogeneous, non-homogeneous. Okay, because the power of x and y here are not the same. Okay, so it is non-homogeneous. Okay, and then is it autonomous? No, of course they answered this one, so it's non-autonomous. Why? Because we can see x and y explicitly in this equation, so it is none of those. It's not autonomous, sorry. Okay, number 4, that's ABC, sorry, A, B, C, D. Okay, so the D part, they said y prime prime plus 4y equal to the sine of y. Okay, what's the order? The order is 2. What's the degree? The degree is undefined. Remember I said once there is the presence of a transcendental function on y, then it makes the degree to be undefined, because we do not know what the degree of this y is. because it's possible the degree of this y is let's say raised to the power of a fraction that we will need to clear and then be able to know what the exact degree of y prime prime is. So because we are not sure and we can't clear this sign, so we say undefined, right? Linear, non-linear. Okay, of course this transcendent. Once is the degree is undefined, is automatically non-linear. Okay, homogeneous. Okay, because of this place, of course you state that it is non-homogeneous. Okay, so non-homogeneous. All right, autonomous, sure, it's autonomous because you can see all the equation is in terms of y. Okay, there's no x explicitly there, right? Then number 5, we have the square root of 5 plus y prime prime raised to the power of 3 equal to y prime. Okay, so this is going to be a typical illustration of what I've been saying about clearing whatever fractional power you have. For instance, here we need to clear this square root to this other side to be able to know what this function is really, and that will help us determine all the properties. So this is actually y prime raised to power of 2. So we have removed every fractional index. So let's begin. Is this one now, what's the order? The order is the highest derivative present, which is 2. So it's order 2. What is the degree? The degree is the power of the y with the highest derivative, which is 3. And what is linearity? Of course, non-linear. You can see this has power 2, this has power 3. Remember we said once the power of y or its derivative is not 1, then it's non-linear. Okay, is it homogeneous? Of course, you can see what we have. There is a constant here, so it's non-homogeneous. Okay. Is non-homogeneous. It is this sign here that made this one non-homogeneous. Here is the constant, the presence of constant. Remember that what allows for homogeneity is that you have all y equal to 0. Here now is all y, but there is the presence of a constant. Okay, it cannot be equated to 0. Instead, you will equate it to maybe -5 or whatever. All right. So, and then is it autonomous? Yes, because of course, everything is in terms of y, so is autonomous. All right. So finally, finally, we can check the last one. Oh no, don't like that. Okay, let me use this for the last one. Let me draw to this point. Okay, for the last one, which is f, was the differential equation. Look at it here. It says x plus 2xy cubed, then dx, then plus we have y cubed plus 2x squared y, then dy is equal to 0. Okay, so this is what we have here. Is it let's begin. Is it what's the order? Of course, the order is 1. By the time you make dy dx the subject, it will just be only dy dx, not more than one derivative. Okay, then what is the degree? Of course, the degree is going to be 1 if you make dy dx the subject, so the power will be 1, so the degree is 1. Is it linear? Of course, no, because you are seeing the power of some y to be more than 1. So here is 2, here is 3, so it's non-linear. Is it homogeneous? They use their hand in answering that one. It's non-homogeneous. Okay, of course, you can see the reason why it's non-homogeneous. there is heterogeneous power of x and y here. The power of x here is 1, while the power of y here is 2. This one may have allowed for homogeneous equation, because if you sum, okay, no, the power of x here is 2, the power of y here is 1. Okay, so it's non-homogeneous. And then finally, is it autonomous? The answer is no. Okay, sorry, see what I'm writing. It's non-autonomous. Okay, so and why is it non-autonomous? Because you can see that there is x and y explicitly written in this particular differential equation. All right, so and that is a completion for problem 1. Okay, so we go over to problem 2. So what's the question? For this problem, I'm going to be reading from the material. I'm not going to be writing it. Okay, it says, okay, let's just try. It says, present a differential equation that represents a family of lines that pass through the point 2 and 5. Okay, so if we have a family of lines passing through the point, it's going to be something of this nature. Of course, they gave that hint in the material. Let me draw it so that you'll be able to see what that is saying. So here is y and here is x, and then of course you have let's assume here is 5, and then this point here is maybe 2. It's just a sketch. Of course, you can draw this to this point and then this to this point. So what it means is that these lines are going to be meeting at this point. Okay, so all the lines you're talking about are going to be lines, or let me use another color for that. Okay, so they are going to be lines that will meet at that point. So they are of the family that will pass through the point 2 and then 5. Okay, let me also bring this. Okay, so you have something like this. Okay, and so on and so forth. Okay, so you can even have something of this nature. So all of these are points represented by this particular family. All of them pass through this same point, and that point there is your 2, 5. That's x value is 2 and y value is 5. Okay, so and they're asking us to get an equation that represents it. Okay, so all that you need to do here, which they started for us on the solution side, is to first of all get the equation that represents this straight line, the general equation that represents them. And how do you get that general equation? We are told that to form equation of a line, you need y minus y1 equal to the slope, which is m multiplied by x minus x1, where your x1 and y1 are the values of x and y from this point. Okay, so and then if you go to that solution hint they gave, what they did is that they have y minus, our y1 is 5, and then they represented our m with a, and then you now have x minus 2. Okay, and that was the first equation they gave us, which is of course the general equation representing all these lines. The slope can be different, but they are meeting at the same point 2 and 5. So, and the slope here is the a. That's why you're having different slopes like this, but they are all passing through that point. And then to now, after you've gotten this, then from there you can move to now generate the differential equation that will represent that family. And how do you do that? You eliminate the arbitrary constant. And how do you eliminate the arbitrary constant? You will get one derivative, since it is only one arbitrary constant. So all I need to do is open up that bracket. That will give me 5 y minus 5, or let me transfer the 5 to the other side. So I'll have y is equal to ax, that's this times this is ax, and then a times this is minus 2a, and then 5 coming over here will become plus 5. All right, so from this equation I can get my y prime by differentiating across board. So if I differentiate this, I get y prime. If I differentiate this, I'll get a. Of course, this one is a constant. A is a constant, multiplying a constant, both will be constant. Okay, so if you differentiate, you get 0. If you differentiate this, you also get 0. And so you see that our y prime will be equal to a. And so all we need to do now, which they even told us there, is now to substitute the value of this. They called this equation star. They told us to call that equation star. And then we are to substitute it into this particular function here. So once we do that, make your y prime the subject, and that is your solution. Okay, and to do that, what do we mean? Or let me leave it this way. Okay, so what we mean is that, of course, you are going to get that your y minus 5 is equal to, your a now is equal to y prime. So you have y prime into x minus 2. And you are done. Therefore, our y prime is equal to y minus 5 all over x minus 5. That's dividing both sides by x minus 2. Dividing both sides by x minus 2, we will get this. And this is the required differential equation. Remember, you can as well stop here. You can just put it here and leave it this way. Or even from here now, you can open the bracket. For instance, see what I'm saying. I could choose to do y minus 5 is equal to xy prime, then minus 2y prime, and then I can arrange everything to one side, and that will give me, let me say, okay, instead of opening this bracket, let's leave it together. That's x minus 2y prime. Of course, this one coming over here will be minus y. This one coming over will be plus 5. Everything equal to 0. Okay, so this could also be another way of arranging the differential equation, or you can keep it this way. Any of those will give you a beautiful solution. All right, so that's the differential equation that will represent the family of straight lines that will pass through the points 2 and 5. Okay, so let's look at problem. So we look at problem 3. Yeah, if I'm correct. Okay, so for module 2, we've been able to look at problem 1 and 2. So let's consider problem 3. And what is the question there? Maybe I should bring back my big this thing. All right, so what did problem 3 say? It says that find m so that y to the equal to e to the power of mx will be a solution of the equation look at the equation here. Y prime prime plus y prime minus 6y equal to 0. Okay, so you are looking for what will be the value of m that will make this particular y a solution to this differential equation. All right, remember I said that one of the things you're going to be seeing is how to show that a function, or how to determine if a function is a solution to a differential equation. Okay, so look at this now. How do you do that? All you need to do is to substitute this y here, just as when you have a linear equation. For instance, I have x plus 5 equal to 2, or let me say equal to 8. Okay, so how do I get the solution of x, or how do I interpret what will be the solution of this? What the interpretation is that I'm looking for a value that I will add to 5 to get 8. That's actually a value I will substitute here, and this equation will be true. So that's exactly what you're doing here. If we substitute this y into this place, you have 3 positions that contains y and its derivative. If we're able to get the derivative, first derivative, and put it here, get the second derivative and put it here, and then put y originally here, are we going to get 0? So if we're able to get 0, then this is a solution. But if we are not able to get 0, then it's not a solution. So they are now asking us, what value of m will we put so that this will become a solution? All right, so that's very beautiful to do. And what do you do? First of all, bring down our y. Our y is equal to emx. Okay, so from emx we can get our y prime. So our y prime will be the derivative of these once. And when it comes to differentiating e, remember what we did in math 102. So you bring down the e that way, and then multiply by the derivative of the power here, and the derivative of this with respect to x will be m. So I will use it to multiply, and the same thing will happen for prime. So that one is going to give me, of course I'm going to bring down this the same way and then differentiate. So 1m will come again, and when it multiplies this, you now have m squared emx. All right, so it's that beautiful. Okay, and that is going to now give us, so let's substitute here. So I will bring this guy, which is m squared emx plus m emx minus 6 times my y, which is emx. Okay, everything should be equal to 0. So I'm looking for the value of m that will make this truly equal to 0. And how do I do that? Factorize out your e, or emx. So if we bring out emx, we have m squared plus m minus 6, and then that's equal to 0. Actually, we call this the characteristic equation of a differential equation. Don't worry, when we get there, you are going to see that. So our job now is to state that this implies that either emx is 0 or m squared plus m minus 6 is equal to 0. And of course, it's not possible that emx will be 0. There's no index number with a power, of course, and a base that will be equal to 0. There's no how you will make this power or get an m that will make this to be 0. So this cannot be. In other words, we have only this one to solve. So we will try, okay, let me reduce this so that we can be seeing part of the equation. So we will try to solve this now. And to solve it, what are we going to do? So if we multiply the coefficient 1 and minus 6, we'll get minus 6. So we are looking for 2 factors of minus 6 that will add up to m, as that's positive 1, and then multiply to give this. That's 3 and minus 2. Okay, so and for that, all you need to do is to open up your brackets, but let me solve now. So I have plus 3m minus 2m, then minus 6 equal to 0. So here we factorize m into m plus 3. That's for these two, and then for these two, minus 2 is going to do that into m plus 3 as well. Okay, and that's equal to 6. Okay, so what will happen now? Gather the ones outside. and then pick a common one. All right, that's equal to 0. So either m minus 2 is 0 or m plus 3 is 0, and you are done. Therefore, our m is equal to 2 or negative 3. All right, so this is the value of m that will make that our y to be a solution. It's either your m is positive 2 or your m is negative 3. Okay, so and that's the end of question problem 3. Okay, so let's look at problem 4 now. Okay, so problem 4 is a little bit long. I mean the question. So let me try whether to write or to read it. Okay, let me try to write it. Okay, so let's begin. Suppose, okay, so permit me to just write it. Suppose that, or let me increase this before writing. So is that fine? Will that be a better option? Okay, let's try. Okay, so problem 4. Suppose I'm still with you, so I'm trying to write the question. Okay, so let's try to reduce now and see what we have. Okay, so the question says that suppose, okay, so it says that suppose that in a hostel of 964 students, that 2 of the students have contracted, yeah, I think that's what it should be, contracted, not contacted. Okay, so R is missing there. So contracted a deadly virus. Determine a differential equation. Please take note of some of these abbreviations. Determine a differential equation governing the number of people at a particular time, that's x of t, who have contracted the virus, if the rate at which the disease spread is proportional to the number of interactions between the number of students with the virus and the number of students who has not yet contracted the virus. Okay, so this is to show you that one of the applications of differential equation, that's we use it to model problems, model diseases, model drugs, model machine systems, and all of that. Okay, so it's a very powerful course or topic, okay, or concept of maths. Okay, so here, what do you do? Of course, since there are 2 groups of students, so you start by stating that of course, you already have been given x to represent those that have contracted, okay, those with the virus already. Okay, so these ones have contracted the virus, and then we can have yt to be those that are yet to contract the virus. All right, so if we have that, okay, so what it means is, remember, we have a hint here, so which we can always pull on. So here the implication is that the sum of these 2 population, remember your x, those that have not contracted, those that have contracted it plus those that have not contracted it, will give you the total number of students in that hostel at any given time. And the total number of students at any given time is given as 964. Okay, so this was the first thing that we are asked to complete there. We are told to write the value of x of t plus y of t. It will be the total number of students. Okay, and then the second thing the hint gave us is that we should take note that dy dt is equal to kx of t multiplied by y of t, and they called it equation star. And so we are now asked to use that equation to get I think is the differential equation we are looking for. We are trying to model a differential equation that will represent the interaction between those that have the disease at a point and those that do not have it. Okay, so what are we going to do? Now meanwhile, before we continue, okay, they said we should eliminate y of t in equation star. How do you do that? Make y of t the subject from this one and then substitute it here. And if you do that, you will see, assume that this is equation 1. You will see that from equation 1, so from 1, our y of t is equal to 964 minus x of t. So what that will imply is that our dx dt will be equal to k x of t, then multiplying by y of t, we are going to have y of t minus, we are going to have 964 minus x of t, okay? And of course, if you open up these brackets, you will get something in the square of x of t. Okay, but let's leave it like this. Okay, so now okay, so if we subject this to initial condition, and what will be the initial condition? That's the next step they asked us to take. So what's going to be the initial condition here? Now if you go up to that question, let me see if we can go up. I hope it does allow us to do that. If you go up there, you will see an initial condition you are given. And what's the initial condition? They said that determine the differential equation. Okay, look at it. Suppose that in a hostel of 964 students, that 2 of the students have contracted a deadly disease. So the initial condition given is that 2 already have the disease before this study was asked to be done. Okay, so before we are able to determine this, already there were 2 students that had the deadly disease. Excuse me. Okay, so if that is the situation, so what that means is that at the point of this study, that is the population of those that had the disease at the time t equal to 0, because you've not done anything at that point. So at your t equal to 0, that the number of students that had the disease was equal to 2. Okay. All right. So let's see then. Okay. So now what? Okay, that's just all actually. So you can decide to open this. So this is actually an IVP, an initial value problem. So we can actually write it this way. Remember, we can put x as prime, to be equal to kx, that's, let's avoid repeating that t, into 964 minus x. Okay, so where your condition is that x of 0 is equal to 2. Okay, so this is the desired differential equation according to what the steps we are told to follow is. Okay, so and so we've been able to take question 1 through question 4. All right, I think is a good time to have a break, and then we'll continue from here in the next video. Meanwhile, I'm not sure I've given a breakdown of this. Okay, so module 2 has 10 questions. Okay, so the next section we are going to take from number 5 to number 10. Okay, hopefully, and then we get into module 3, which has about module 3 has about okay, I think it's about 10 questions as well. Yeah, and then you have module 4. Okay, and module 4 has, let me check, module 4 has about 5 questions. Then there is module 5, which has which is the last module, and it has 5 questions also. Okay, so gradually we will be able to finish this. So in the next video, I'm hopeful that module 2 would have just 2 sections. So in the next video, we'll do questions 5 to questions 10, and then get into module 3, and so on and so forth. Okay, so kindly subscribe to our channel and do give a thumbs up to this video. Pending when you will see this video, if there is availability of membership, do consider joining the community of this channel. You will have opportunity to learn more if you become a member of the channel, and then we will see you in other videos. Bye.